we're going to use coterminal angles. Coterminal angles to find the exact answers. I'm not sure I spelled angle right there. I'm always wondering, am I spelling angle or angel? Okay, I think it's angle. All right, so the first one, part A, is the sine of 390 degrees, while the second one, B, is a secant of 420 degrees. So let's do part A. Well, first, for part A, let's draw the x and y axis, and let's label in degrees the quadrantal angles. 0, 90 degrees, 180 degrees, 270, back up to 360. And then we're going to swing around 360 degrees plus a little more to get to our 420 degrees. Okay, our 390 degrees. And that implies that theta is coterminal to the angle 390 minus the 360 round trip that we took equals 30 degrees. In the first quadrant, we see that it's coterminal to 30 degrees. We know something about a 30-degree angle. We have this 30, 60, 90 triangle, 30 degrees up on the top and 60 degrees down in the corner, 1, 2, square root of 3 on the sides. And the sine of 390, which is what they're asking us, degrees, is equal to the sine of 30 degrees, which is equal to the opposite over the hypotenuse of 30 degrees, which is the upper angle in the sketch, which is 1 over 2. Now, I just want to say something before we continue. Had this terminated in a quadrant other than the first quadrant, we would have had to make one more consideration. What is the sign of that trig function in that quadrant? See, in quadrant 1, all the trig functions are positive, so there's no issue there. But had we terminated in quadrant 2 or 3 or 4, then we would have had to ask, well, what is the sign on the trig function? We'll see something like that later. But these two examples, they both terminate. They're coterminal to angles that are in quadrant 1 where all the trig functions are positive. So we don't even worry about that issue here. Secant of 420 degrees. Okay, part B. Let's draw our x-axis and our y-axis and label it again with degrees. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees going in a counterclockwise direction, then back to 360 degrees. Okay, so we're going around, let's see. Oh yeah, if we go around another 90 degrees after 360, we get to 450. I just added that 90 to 360 and got 450. I need to go around 420 degrees, so I swing upward and go a full round trip and a few more degrees. And what is that? It's the coterminal angle, but what is it? It's coterminal to 60. Here's how I know. The secant of 420 degrees is equal to the secant of 60 degrees, and the reason why is because I subtract 360 for that one round trip, and it left 60 degrees. Okay, so now what do? I am looking at the same triangle in the cloud on the far left of this page, the 30, 60, 90 degree triangle, but now I'm looking at the 60 degree angle, which is in the lower left corner, and I'm using the definition of the secant. The secant is defined under a right triangle to be equal to the hypotenuse over the adjacent. It's the reciprocal of the cosine function. Hypotenuse over adjacent. Well, the hypotenuse on that sketch is 2, and the adjacent side to 60 degrees is 1. So this theta, this secant of 60 degrees is the hypotenuse over adjacent. It's equal to 2 over 1. So our secant of 420 degrees is equal to the number 2.